So what I would like to do is just spend a minute doing a couple examples of how to simplify the quadratic formula. So the example that we have in front of us says, use the quadratic formula to find the exact solution of the following equation. So it's pretty straightforward. We have a leading coefficient of 1, a b value of 6, and a constant of 4. And we're going to use the quadratic formula to solve because we can't factor this quadratic. So we have x equals negative b, and since our b is 6, we have a negative 6, plus or minus the square root of b squared minus 4ac, and this is all over 2 times a. So simplifying this a little bit, we have negative 6 plus or minus the square root of, and if we do 6 squared minus 4 times 1 times 4, so all of that underneath the radical sign all at one time, we should end up with 20 all over 2. So from here, to have a simplified radical, we need to make sure there are no perfect square factors within this number. So one of the easiest ways to do that is by creating a factor tree. 20 can be factored into 2 and 10, and 10 can be factored into 2 and 5. So the prime factorization of 20 looks like 2 times 2 times 5. Now a perfect square factor is a number being multiplied with itself, and we do in fact have a number being multiplied with itself. When we do, we take that number to simplify our radical, and we put it outside of our radical sign. And anything that doesn't have a partner, like this, we put back in our radical sign. So I like to call this the buddy system. Since 2 had a buddy, it got to leave our little house, and since 5 did not have a buddy, it had to go back in the house. And this is all over 2. Now we need to look and see if we can simplify the fraction, and we can. Negative 6 is divisible by 2, and this 2, for the second piece of this, is also divisible by 2. So negative 6 divided by 2 is equal to negative 3, and 2 divided by 2 is 1. So our quadratic simplifies to negative 3 plus or minus the square root of 5. And if we need to write these individually, it looks like negative 3 plus the square root of 5 and negative 3 minus the square root of 5. So we only simplify this fraction if both this number is divisible by the denominator and the number in front of our radical is also divisible by the denominator. So let's look at another example. So do this one more time. We have x squared minus 14x minus 4. So again, a is equal to 1, b is equal to negative 14, and c is equal to negative 4. So plugging this into the quadratic formula looks like x equals a negative b, and since our b is negative 14, it's a negative 14 plus or minus the square root of negative 14 squared minus 4ac all over 2a. So an important thing here that we need to make sure we're aware of is that the negative 14 is being squared, so we need to make sure we put it in a set of parentheses, because if we do negative 14 without the parentheses squared, we'll end up with a negative result, but we are squaring negative 14, so negative 14 times negative 14 should end with a positive result. So simplify this expression. The negative here gives me a positive 14 plus or minus the square root of, and if we'll do negative 14 squared minus 4 times 1 times negative 4, we should get 212 underneath that radical sign. So we have 14 plus or minus the square root of 212 divided by 2. So first, we need to see if this radical can be simplified. One easy way to do that is to create a factor tree. So 212, I know since it's an even number, it's divisible by 2. So 212 divided by 2 gives me 2 and 106 as factors. I know 106 can be divided by 2 because it's an even number. So this is 2 and 53. And 53 is a prime number. So the prime factorization of 212 is 2 times 2 times 53. For factorization or for simplifying radicals, if you're going to do prime factorization, anything that has a buddy gets to leave this radical sign, and anything without a buddy has to go back inside. So right here we have a pair of 2's. That means we get to go outside of our radical sign with that 2 and back inside with the 53. And this is all over 2. Now to simplify the fraction, we look and say, can this number be divided by 2 and can this number be divided by 2? And the answer is yes. 14 divided by 2 gives me a 7, and 2 divided by 2 will give me 1. So I have 7 plus or minus 1 square root of 53, or 7 plus the square root of 53, and 7 minus the square root of 53.